Question number 27, again UPSC CSAT 2024. A question is given followed by two statements, first and second. Consider the question and the statement. Question is, what are the values of m and n where m and n are natural numbers? Statement first says that m plus n is greater than mn, where m is greater than n. The product of m and n is 24. This one is the second statement. You have to tell the values of m and n, means you have to tell the exact value of m, you have to tell the exact value of n, you have to tell the exact value of n. See, statement number first, it says that m plus n is greater than mn, where m is greater than n, m is greater than n. So we have many values which satisfy this statement. Here how I have to take m greater than n. If I take m equal to 2 plus 1 is greater than 2 into 1. See, 2 plus 1 is 3 and 2 into 1 is 2. As you know that 3 is greater than 2. If I take it n is equal to 1, 3 plus 1 is equal to 4 and 4 is greater than 3. I can write infinite values which satisfy this relation. So if I have infinite values of m and n, so how I can tell you the unique values of m and n? Means statement first is failed. If I move to the second statement, what second statement alone says that the product of m and n is 24, means m into n is equal to 24. See, m and n are natural numbers, means they are complete numbers. How you can write 24? It can be written as 24 into 1. It can be written as 12 into 2. It can be written as 8 into 3. And it can be written as 6 into 4. So what I have? If I take m is equal to 24, then n is equal to, if I take m is equal to 24, then n equal to 1. If I take n equal to 24, then m equal to 1. Means this condition will tell me two values of m and two values of n. Again this one will tell me the two values, because here if m equal to 12, n equal to 2. If m equal to 2, n equal to 12. So second statement also fails to tell me the exact value of m and n. If I add these two statements, if I add these two statements, so what I get from the first statement, I will get that m is greater than n. M is greater than n, so I can take these values, these four values only. Here m is equal to 24, n equal to 1, m is equal to 12, n equal to 2, m equal to 8, n equal to 3, m equal to 6, n equal to 4. In all these four multiples, we have m greater than n. Again, we have also condition m plus n is greater than n. If I take the value here 24 plus 1 is greater than 24 into 1. See, 25 is greater than 24. Means this statement clarifies m and n. If I take any of the statement, if I take second statement, if I take second multiple, if I take this product here, 12 plus 2, 12 into 2, 14 is less than 24. And what I have to make? M plus n is greater than n. So I will not take any of the values here. All the values are false. Where? How? Here m plus n, 8 plus 3 is 11. 11 should be greater than 8 into 3, that is 24, which is not possible. All of us knows that 11 is not greater than 24. So we have exact value of m and n. M will be 24 and n will be 1. So the question can be answered using both the statement together but cannot be answered using either statement alone. Option C is the correct answer. Next, a question is followed by two statements. And second, consider the question and the statement. What are the unique values of x and y? Again, you have to tell the unique, means unique exact value of x. You have to tell the exact value of x. You have to tell me the exact value of y. Where x and y are distinct natural numbers, means they are distinct, means they are different, and they are natural numbers, means they can take values from 1 to n, and n is nothing, just infinite or the last value of that sequence. Statement first says that, what statement first says, if I divide x by y, I get an odd number. I have numerous value of x and y which will give me an odd number when I divide x by y. See, if I put x is equal to 15 and y equal to 5, I will get 3. 3 is an odd number. If I take x is equal to 21 and y equal to 3, I will get 7. 7 is also an odd number. So I have, if I take x is equal to 33 and y equal to 3, then I have 11. 11 is also an odd number. So statement first is not correct, or statement first is not sufficient to answer my question. And my question is that, is x, can I tell the exact value of x? Y? I cannot tell exact values of x and y by using the statement first. So I will move to the statement 2. What it says that xy is 12. Xy is equal to 12. It can be possible in 2 to 3 ways. How? If x is equal to 12, then y equal to 1. Or if x equal to 1, y equal to 12. So I have two values of x and y. I cannot tell two unique values by this product only. And I have another product, whether it is 6 into 2, whether it is 4 into 3. So I have 6 possible values of x. X can be 12. If x is 12, y equal to 1. X can be 1, then y will be 12. So we have 6 values of x or 6 values of y. So statement 2 also fails. So we have to combine both the statements. If we will combine both the statements, what will we get? What will we get? See, from this statement, we have to take x and y. See, if x is, this also explain that x is greater than y, because the numerator is greater than the denominator. That's why we are getting a constant which is an odd number. So we have to take, either we can take x is equal to 12 or y equal to 1. So 12 upon 1, if I take x equal to 1, y equal to, x equal to 12, y equal to 1, I will get 12 is not an odd number. If I take x equal to 2, y x equal to 6, y equal to 3, I will get an odd number. If I take x equal to 4, y equal to 3, I will not get any number. I will not get any. I will not get any number, because 4 by 3 is nothing but a fraction. So this one is not possible. This one is also not possible. So what we have? I have values of x. What it is? It is 6. We have x equal to 6 and y equal to 2. Question number 29. Try to solve this question. We have a drink break. Continue. A question is given followed by two statements, first and second. Consider the question and the statement. Here are three distinct prime numbers whose sum is a prime number. See, we have three prime numbers. So I will write a set of prime numbers. I will write a set of prime numbers. What it can be? See, 2 is a prime number, 3 is also a prime number. 4 is also not. 4 is not a prime number. 5 is a prime number. 7 is a prime number. 11 is a prime number. 13 is a prime number. 17 is a prime number. 19 is a prime number, and so on. We have numerous prime numbers, and we have to take only 3 of these numbers. I have to take only 3 of these numbers. Question: what are those 3 numbers? I have to tell what are those 3 numbers. I have to tell the exact numbers. Means I have to tell you I have to tell you these 3 numbers, not in a sequence, because they are not given as x, y, and z. Just I have to tell what the 3 numbers are. Either they can be 3, 5, or 7, or I can add 7, 5, 3, or 5, 7, 3, or 5, 3, 7. So I have to tell only those 3 numbers. See, I will go to the statement number first. If you I go to the statement number first, it says that if I consider them x, y, and z, it says that x plus y plus z is less than 23. Is less than 23. Is less than 23. See, if I take this statement, see, the smallest value of x, y, and z can be x plus y plus z. If I have to write the smallest value of x plus y plus z, which is a prime number, the sum is a prime, then sum should be prime number, but I will write the exact value, exact smallest value of x plus y plus z. This will come from the smallest number, 5, 3, 8 plus 2, 10. So 10 can be the smallest number, and this number is not an prime number. So I can write the sum x plus y plus z is equal to prime number. So the number should be either 10, 10 is not a prime number, or greater than 10. See, I can write x plus y plus z equal to either 11, 11 is a prime number, either 13, either 17, or 19. Either 11, either 13, either 17, or either 19, because these prime numbers are less than 23, or the minimum value of x plus y plus z can be 10. So the number which is greater to 10 and is a prime number is 11 itself. See how I can write x plus y plus z equal to 11. If I take x plus y plus z equal to 11, can I make, can I select 3 numbers from this set of numbers which will help me to make the sum 11, 13, 17, or 19? See, if I have to make a sum equal to 11, means if I add these numbers, see, 3 plus 5 plus 7, see, next, see, I can write 2 plus 3 plus 5, or I can write x plus y plus z. If I add another 3 number, that is 3 plus 5 plus 7, 7 plus 5, 12 plus 3, 15, means the number should be greater than 15. The number should be greater than 15, because the second smallest sum, the second smallest sum, listen carefully, the second the second smallest sum that I can write is what? See, if I eliminate these 3, the second smallest sum that I can write, see, if I take 2, 3, or 7, 7, 3, 10 plus 2 is 12. So I cannot take 11 as the sum. I cannot take 11 as the sum. Next is smallest sum. Next is smallest sum. See, if I add 2 plus 3 plus 11, see, if I add 7 plus 5 plus 3, see, if I take 2 plus 5 plus 7, 7 plus 5 is what? 7 plus 5 is 12 plus 2 is 14. So I cannot take 13 as my value. So 13 is also not possible. 13 is also not possible. This question is very very trickiest question, because there is a chance, there is 100% chance of you to make this question incorrect. The third is smallest value what you can take, because I cannot make some 11, I cannot make some 13. Either you can add this, or this is the perfect way to eliminate all those numbers, all those prime numbers, which is the sum of the all prime numbers. See, the third, we can see the third is 14. Next biggest sum, the next, sorry, the next is smallest sum. What it can be? If I take 3 plus 5 10, 10 plus 2 12, I have already taken. 3 5 plus 3 8 plus 2, I have taken. If I have take 2 plus 5 plus 7, I have take 2 plus 5 plus 11. I will take 2 plus 5 plus 11, 2 plus 5 plus 11. So 11 plus 5 is equal to 16 plus 2 18. 18. So I cannot take 17 as the sum. So next is smallest sum I can take. What I can take? 3 plus 5 plus 11. 5 plus 3, 8 plus 11, 19. And 19 is a prime number. 19 is a prime number. Yes, it can be achieved. How? If I take a set, what it is? 3, 5 and 11. 3, 5, 11. 3, 5 and 11. This is the first statement. This is the gist of the first statement. You can get a set. What it is? 3, 5 and 11, because 5 plus 3 8 plus 11 is equal to 19, and 19 is a prime number, and all these three are prime numbers. So move to the statement 2 alone. What statement 2 says? Statement 2 says that one number is 5. One number is 5. See, one combination is this, is equal to 19, because in statement 2 it says that if you take one number as 5, then you can take another two values which will make a unique prime number. See, we have made a prime number, we had made a unique prime number which is the sum of these three prime numbers, but I have numerous such sums. How it is? If I take 5 plus, can I make 23? Yes, I can make 23. 5 plus 7 plus 11 is equal to 23. So I have another set. Can I make 29? 5 plus 11 plus 13. Yeah, I can make 5 plus 11 plus 13 is equal to 29. So this one is also prime number. This one is also a prime number. This one is also a prime number. I have taken 5 in all these three cases, but scenario changes. How? Here other two numbers are 3 and 11. Here other two numbers are 7 and 11. Here other number are 11 and 13. So from statement 2 I cannot clearly tell what are those numbers. So my statement number first is correct and sufficient to answer this question. So read option number first. The question can be answered by using one of the statement alone. It means that either of the statement is sufficient to answer, but cannot be answered using the other statement alone. It means that if this statement is correct, then this statement is wrong. So I have done the past post-mortem of this question. This one is the question that all, mostly all the students have done it incorrect, because they have seen that 5 is there, 5 3 11, so they pick this option, they combine both the equation. But the correct answer of this question is this. The correct answer of this question is option.